Welcome to Intelligence Gateway.
Akamai Network Engineering. Lecture 10. Network Optimization and Performance. Tuning. Optimizing network performance, why it matters. Performance optimization techniques. Bandwidth management and optimization. Reducing network latency and jitter. Network optimization tools and methodologies. Putting it all together, best practices for network optimization. Optimizing network performance, why it matters. In today's fast-paced business landscape, network optimization and performance tuning are more important than ever. With the increasing reliance on cloud-based applications and remote work, a slow or unreliable network can have serious consequences for productivity and profitability. Optimizing network performance can improve the speed and reliability of data transfer, reduce downtime, and ensure that critical applications are always available when they are needed. By implementing best practices such as load balancing, caching, and compression, businesses can achieve significant improvements in network performance. Performance optimization techniques. One of the most effective techniques for optimizing network performance is load balancing. This involves distributing network traffic across multiple servers to ensure that no single server becomes overwhelmed. Load balancing can be achieved through hardware or software solutions and can significantly improve network performance. Another technique for optimizing network performance is caching. Caching involves storing frequently accessed data in a local cache, which reduces the need to retrieve data from remote servers. This can result in faster response times and reduced network traffic. Compression is another technique that can be used to optimize network performance by reducing the size of data packets that are transmitted across the network. Bandwidth management and optimization. Bandwidth management and optimization are critical components of network performance. Effective bandwidth management ensures that network resources are allocated efficiently, minimizing the risk of bottlenecks and slowdowns. Optimization strategies such as quality of service cost policies can help prioritize traffic and ensure that mission-critical applications receive the necessary bandwidth. One effective strategy for bandwidth optimization is the use of caching. By storing frequently accessed data closer to the user, caching can reduce the amount of bandwidth required to transmit data over the network. Other strategies include compression, which can reduce the size of data packets, and load balancing, which distributes traffic across multiple servers to prevent overload. Reducing network latency and jitter. Network latency and jitter can have significant negative effects on network performance. Latency refers to the delay between sending and receiving data, while jitter is the variation in latency over time. To reduce latency and jitter, one strategy is to implement quality of service cost policies, which prioritize certain types of traffic over others. Another approach is to use buffering and queuing techniques to manage traffic flow and reduce congestion. Additionally, optimizing network routing and using high-speed links can also help reduce latency and jitter. Network optimization tools and methodologies. One of the most important aspects of network optimization is monitoring and analyzing network traffic. Network monitoring software, such as Wireshark and SolarWinds, allows you to identify potential bottlenecks and other issues that may be impacting network performance. By analyzing network traffic, you can gain insights into how your network is being used and identify areas for improvement. Another useful tool for network optimization is network traffic analysis. This involves examining network traffic patterns to identify potential issues and opportunities for optimization. For example, you may discover that certain applications or devices are consuming a disproportionate amount of bandwidth, which can be addressed through load balancing or other techniques. Graphical representations of network traffic patterns can be particularly helpful in identifying these issues. Putting it all together, best practices for network optimization. To achieve optimal network performance, it's important to implement a combination of techniques and strategies. Load balancing, caching, and compression are effective ways to optimize performance, while bandwidth management and optimization can help ensure that resources are being used efficiently. Additionally, reducing network latency and jitter can have a significant impact on overall performance. However, it's not enough to simply implement these techniques and strategies. It's crucial to constantly monitor and analyze network performance using tools like network monitoring software and network traffic analysis. By doing so, you can identify areas for improvement and make necessary adjustments in real time.
Thanks for watching. For more information, like, comment, and subscribe our channel.